Hello, Advanced Algebra 2 Trig. These are the must-know parent functions that we have to be able to sort of draw and sketch and know lots of things about. Okay, so grab these notes if you need to and follow along with me. I'm gonna do this in blue for you. We need to be able to name the function. We need to be able to say the algebraic expression for the function. We have to be able to talk about the shape of the function. We need 3 key points and then the domain and the range. So I'm going to show you what these are. So go ahead and follow along with me if you need to, or just watch this if you want some help coming back to it. All right, the first one is just linear, okay? Hopefully that's not a big deal. This is the function f of x is equal to x. Notice we're using function notation since we're talking about all these sort of parent functions. So the algebraic way of describing this is f of x is equal to x. For domain and range stuff, we've talked about this in this unit. So domain is all the x values. So as you're cruising along the x-axis, is there any spot that I cannot point to on the graph and doesn't seem like it? Same thing here. Every single spot is looking pretty good. So the domain for this is actually all real numbers. And then similarly for the range, is there any spot on the y-axis that I can't point to or have an output, if you will? And the answer is no as well. So in this case, the range is also all real numbers, and that's how you can represent that. The second one over here is quadratic. Okay. The expression for this one is f of x is equal to x squared. Hopefully that's not a big deal for everybody. So I'll write that here on the graph for you. F of x is equal to x squared. It makes a parabola. That's also a name for it. The domain for this, again, any x values that we can't plug in, the answer is no. So the domain is all real numbers. However, the range, slightly different, right? Notice that the y values only exist when y is greater than or equal to 0. So I have no y value like of -3. Like if I look left and I look right, there is no graph that I can see, right? Same thing for down here at -5. If I looked left and I looked right, there is no y value I can see. But obviously when I get to 4, I can find some y values. When I get to 3, I can find some y values. So the range is, one way to represent it would be all the set of all real numbers y, such that y is greater than or equal to 0. Now we can say 0 because 0 is part of the graph. If you look right there, 0, 0 is part of the graph. So that's quadratic. There's the first two. We got linear and we got quadratic. Third one, bottom left here. This is square root. So I'm going to abbreviate here since I'm kind of running out of room here. So this is the function f of x is equal to the square root of x. So algebraically, that's what we're going to write here. F of x is equal to the square root of x. Now, it's a good idea to start talking about where I'm getting these points from, okay? As you know, if you plug in a 0, right, then you just get out what we're doing. So f of x equals x, so whatever the x value is, the y value is also. That's what I was trying to say. So 1 for 1, if x is 2, y is 2. If x is 4, y is 4. On this one, if x is 0, x 0 squared is 0. If x is 1, 1 squared is 1. If x was 2, 2 squared would be 4. So I can easily just find these points. For the square root, right, if I do 0, the square root of 0, of course, is 0. If x is 1, the square root of 1 is 1. So that means the point 1, 1 has to be on the graph, which it is. And then this other easy point over here, the square root of 4, right? If x is 4, of course, that's 2. That's why that point 4, 2 is on the graph. So we need to be able to do those, too, for all of these. Domain is, if you look on the x-axis, you have the set of all real numbers x such that x's are greater than or equal to 0. There's no x's over here, obviously. And that is the exact same thing for your range for your y's. So it is all real numbers y such that y is greater than or equal to 0. And I'm using set notation for all of these. Okay, the fourth one here. This is cubic. Let's keep this thing moving here for you guys. This is cubic. So this is f of x is equal to x cubed. Again, 0 cubed is 0, 1 cubed is 1, -1 cubed is -1. That's how I got those 3 points. So algebraically, f of x is equal to x cubed. That's how we say that one. Domain is all real numbers. Range is also all real numbers. Okay, I'll move that up for you. All right, we've only got 2 more to go. This one down here is absolute value. Absolute value, kind of like running out of room, so I'll abbreviate it there. The way we write this is f of x is equal to the absolute value of x. So we have these little bars here, f of x is equal to the absolute value of x. And what that means is, if you give me a 4, they'll take the absolute value of 4, and the output would be 4. But if you give me negative 4, well, the absolute value of negative 4 is also 4. So what happens is you get this, we call this the V-shaped graph, or the V graph. The domain is all real numbers, but the range, as you can see, is only if y's are greater than or equal to 0. So we'll say the set of all real numbers y such that y's are greater than or equal to 0. All right. And then the last one. This one is a funky one, and this is called the reciprocal function. So that's R-E-C-I-P-R-O-C-A-L, the reciprocal function. And this one is f of x is equal to 1 over x. That's what reciprocal means. Reciprocal means 1 over. So the algebraic way of saying that is I just wrote it down for you. F of x is equal to 1 over x. Now let's talk about the domain and range. This one's a little bit tricky. So notice that there is a vertical asymptote here. We'll talk more about vertical asymptotes when we study rational functions, but I cannot plug in a 0 there, obviously, because I can't divide by 0. So we're going to say all real numbers x such that x does not equal 0, and that's my set notation. And then similarly with the range, you can see here there is a horizontal asymptote. So the lines, the function values are approaching 0 but never quite get to 0. So we're going to say the range is all real numbers y such that y doesn't equal 0 either. Okay? All right, those are your 6 parent functions that we need to know. If you have any thoughts or questions about this, please bring them to the class, and see you then.